Hey, hi, good evening, everyone. Good evening, friends. Welcome back to our 30 days free short term training from Python to AI. Right, so we'll quickly understand what we have covered yesterday, then we'll jump into the actual class for the day. Right, so yesterday we understood, a few steps under data pre processing. So we actually started data pre processing. Under data pre processing, also called as data cleansing. So we understood typecasting, which is nothing but conversion of one type to the other. Then handling duplicates. The duplicates that we have in our data should be identified and dropped. Then treating outliers. The extreme values are nothing but the outliers. So if we have outliers, we are supposed to use any one of the technique, and those outliers should be treated. So typecasting, handling duplicates, outlier treatment, then you know. So here only under outlier treatment we discussed winsorization, and I asked you guys to go through the documentation of winsorizer function. Yes, right. Then yesterday we understood zero and near zero variance. Near zero variance. Okay. So what is the importance of such kind of columns? If a column is having zero spread, if the variance is zero or if the variance is close to zero, are we going to consider those columns or are we going to consider those features? So everything was being understood with respect to zero and near zero variance. Post understanding zero and near zero variance, we understood discretization. What is discretization, friends? What is the purpose of discretization? What exactly is discretization? Discretization is nothing but converting your continuous data into discrete data. Okay, so if you have any continuous data, the data which is generally represented in the form of decimals. So this continuous data can be represented as discrete data. What does that mean? Okay, yesterday we understood, taking engine size, which is continuous. So we worked on engine size column, and this engine size column was being discretized. Okay, so if you are trying to convert the values of engine size into two discrete values, that process is called as binarization. Okay, and more than two. If you have more than two bins, then it is called as discretization. What function is used under discretization? What function is used to perform discretization? Cut function. Good. Cut function is used, cut function is generally used for performing discretization. Cut function is present in which library, which module? Cut function is available under which module? Pandas module. Good. So it will be like pandas dot cut function. Okay, so within the function you have to specify the bins, the data, the labels, and all. Have you gone through? It's not feature engine. Okay, it's not feature engine, but you know, Excuse me. It is actually pandas module, pandas package that we have used, and I asked you guys to go to the documentation of cut function which is available in pandas. So if you haven't visited the documentation, the official site of pandas, just go to the official site of pandas and, you know, at a glance understand the documentation of cut function. Right. Then, so, everything was being discussed, and the last topic that we have understood is dummy variable creation. What is the purpose of dummy variables creation? What do you mean by dummy variable creation? Come on, friends. What is the purpose of dummy variable creation? Dummy variable is nothing but, a variable which is actually dummy is what we are creating. But what is the purpose? Why should we create dummy variable? We understood concept, right? We did not go for hands-on, but we understood the concept. Why did we create dummy variables? It's actually, converting non-numeric data to numeric. Categorical data will be converted to numeric data. Good. Why? Why should I convert? Because, how can we use categorical data, or how can we use non-numeric columns in the next phase, nothing but model building phase? How is it possible to build a equation, a mathematical equation using a non-numeric column? Okay, so it's not possible. That is the reason we are converting this non-numeric column, a categorical column, into numeric column. Right? That is what dummy variables or feature encoding means. What are the different types or different techniques available under dummy variables? Tell me the different types. Techniques available under dummy variables. One hot encoding and label encoding. Good. So this is actually divided into, it has two types. One hot, label. Okay. So we also discussed how one hot encoding works and label encoding works. Yes. One hot encoding is generally used on inputs or output of the data. Good. One hot encoding is preferred on inputs and label encoding is preferred on output. Hey, what values can you identify when you perform one hot encoding? What will be the values in the dummy variables or the feature encoded columns? You will find only 0 and 1s. Whatever might be the columns, only 0 and 1s. Yes. What will be the values under label encoding? The label encoded column, will it be fixed? It will vary depending on number of categories. Okay, these values will fix. So the numbers that we get in the label encoded column depends on categories. Okay, so in the input data, in your raw data, in your non-numeric column, how many categories do you have? Do you have 5? So obviously you get numbers from 0, 1, 2, 3, 4. You have 10, so you get 0 to 9 numbers. Depending on, no, it's not categorical variables. It depends on the categories present in that non-numeric column. In that non-numeric column, how many categories you have. So that is what label encoding checks and gives the number. Alphabetically, it assigns the value. That's it. Then, how many columns can you get when you perform, or will you get when you perform one hot encoding? Number of columns. Come on, friends, respond. You will get n number of columns. What is this n representing? Categories. Number of categories will determine the number of columns. Yesterday, what did we discuss? Initially, I told you that we have two categories, gender, male, female. So, how many columns did one hot encoding made? Gender underscore female, gender underscore male. Yes. It's not attributes. Attributes means it will change the meaning. You know, you have to make it as number of categories, number of say classes. That will be the right term, but not attributes. Attributes are generally nothing but columns. So completely it is changing the meaning, right? Yes. Number of columns that you get with respect to label encoding data when you perform label encoding. One. Good. See, if you don't understand these, you know, things with respect to one hot and label encoding, you can't understand hands-on. Okay. The question is, these are representing columns. These are representing values, and these are representing on either inputs or output. One hot encoding or label encoding is preferred. So if you understand these three in general, you can work on hot or label. Okay. So number of columns with respect to one hot depends on number of categories. Number of columns with respect to label encoding will be fixed one. Even though if I have 10 categories or 100 categories or 1000 categories or only two categories, for sure the number of columns will be one. Okay, so here there is no change with respect to the columns. In the same way, under one hot with respect to values, it does not depend on number of categories. The values will be fixed 0 and 1 only. Okay, but under label encoding, it depends on number of categories, and depending on the number of categories, it starts from 0. If there are 10 categories, the numbers will be from 0 to 9. If there are 100 categories, the numbers will be 0 to 99. Okay, and how are these values assigned? Alphabetically. That's it. Right? Yes. So this is what we have understood with respect to label encoding, one hot encoding, especially the dummy variables concept. Now let us do it practically on a use case and see how this one hot encoding and label encoding is working. Okay, but I'm not working on inputs output especially. I'm just taking a non-numeric data and I'll show you how one hot encoding and label encoding works. Right. For that, what I'm doing is I'm importing pandas, a module which is used for data manipulation, then reading the data from an Excel file. Okay, so the same data set, friends, cars data set, 428 rows and 14 columns. Then what are we doing in line number 301? What are we doing in line number 301? What is the function that was used? Is the screen not visible properly? Is it clear now? The function that I'm using is drop, and drop function will actually drop the features, the columns. What columns am I dropping? I'm dropping make and model. Okay, I don't want to drop a single column. Since I want to drop many, I'm passing as a list. Why only list? The question is, why only list? Why not a tuple? Or why not something else? Why only a list of strings should be passed? Can someone tell me? If you want to understand the function well, the only is this okay? So what do you mean to say? Since tuples are not editable, they are immutable. So that is the reason I'm using list. That's what you mean to say, right? So what if I use a set? Sets are mutable. Then I can use set also, right? Why only list? No, why only list? The question is why only a list? I don't know how many of you are actually going through the documentation, friends, but if you go through the documentations, you can understand any function till the depth. Okay, I'm not using any indexing, right? Am I using any kind of indexing here? Hmm? So what you can do is go through the documentation of drop. If you understand the documentation of drop, it will be very clear. Let us check here whether I'll get or not. See, drop is the function removes rows or columns by specifying label names and corresponding axis. So what is the axis that I am passing? I am passing axis is equals to 1. What does that mean? It means columns. How can you tell that, Akhil? Because axis takes 0 and 1, right? So if you pass axis is equals to 0, it means rows. But I'm passing axis is equal to 1. So it is clearly telling that these are nothing but columns. The labels are representing columns. So I'll go down and I'll just understand the parameters. What is the first parameter that we have? It is labels. Okay, so labels, what does it takes? It takes either a single label or list like or list like. That is the reason we are specifying the labels in a list. It's not like list is mutable or set is tuple is immutable. Yes, list is mutable, tuples are immutable. That doesn't mean you should not use anything over here. It is already defined. Labels should take only a single label. When you want to drop only a single column, you need not pass a list. You can directly specify that single column. If you want to, say if you want to drop multiple columns, then you are supposed to declare it as a list object. Okay, see, a tuple will be used as a single label and not treated as a list like. So for the people who had a question so far, why can't a tuple be used? When you define only a single label, it is treated as a tuple only, not as a list object. See, okay, so I can clearly say that why did I use list? Because labels take either a single label or a list like object. when should I give up or when should I pass a list? When I want to drop multiple columns or multiple records, whatever it might be. Okay, so if you see, the next parameter that we have is axis, and what values does axis take? By default it is 0. That means it represents index is nothing but rows. Okay, but do I want to remove any rows or columns? So what is the value for axis with respect to columns? It is 1. Okay, either you can pass 1 or columns. Okay, so depending on that, these labels will be dropped. Under help pane you can also go through the documentation of any function, but you'll not get the complete documentation. So that is the reason I'm suggesting you to go and open the documentation in any of the browser. Okay, so this is just as an example. We understood drop function. So under drop, how many parameters do you see, friends? Yes, there is one, you know, variable length argument and keyword variable length argument. Okay, it's a type of method of data frame instance. So this is again a different topic. Let us not jump into that. Okay, I hope it's clear now. Now let me drop these two columns from df. And where am I storing the output? I want everyone to be active and use the chat window. I'll be asking questions. You have to respond. We are storing this output in df1. Good. What will be the size of df1? When I execute line number 301, what will be the size? What will be the size of df1 after executing line number 301? See, good question. Why are we dropping these two columns, sir? The reason is, what is our aim? What are we trying to understand? We are trying to understand variable, okay, dummy variable creation. So this dummy variable creation, can I perform it on make column, model column, type column, origin column, and drivetrain? See, all of these are non-numeric. So I can work on any of these 5 non-numeric columns, but I cannot work on rest of the 9 columns. They are numeric already. How can we create dummy columns with respect to numeric columns? It's not possible. Dummy variables are nothing but encoding any non-numeric column to numeric, right? So out of these, what I'm doing is I'm removing make and model. The reason is, I'll tell you, it's very simple, friends. If you observe properly, there are many makes of the cars and many models. So when you try to especially for this understanding of one hot encoding, I'm just removing this, because if you perform one hot encoding on these two columns, you'll get many columns. Why? One hot encoding depends on number of categories, if you remember. So there are many categories in these models. Each and every thing is a model. So when I try to work on one hot encoding, obviously it gives me n number of columns, which doesn't make any sense. So for that reason, what I'm doing is I'm just removing these two, so that if I perform on rest of the columns, that makes sense. Easily, folks like you who are new to the course and all, who are new to the program, they can understand, they can grab it well, right? Moreover, they that don't they don't contribute any kind of relevance to the use case. I'll talk about that later, but not now. So for that reason, I'm just removing make and model columns. Okay, So I got the output. Majority of you see 428 rows and 12 columns. Good. So let me execute this and let me check what will be the size of df1 428 by 12 where there is no make and model in this data frame. Make model is not there. Perfect. Then what am I doing in line number 304? Because this is not something which was new for us. We have already discussed this topic in pandas module. What are we doing in line number 304? Come on, try to answer. Come on, friends, try to answer. What makes the difference between line number 301 and 304? Good. Keep it up. See, here in line number 301, we dropped columns from df, make and model, right? And we are storing in df1. The output we are storing in df1. But go and check df. Do we have make and model? Yes, we have make and model still in df. Make and model are still present in df data frame. So what I am doing is, what makes the difference between line number 301 and 304 is, in line number 304, I am performing in place operation. By default, the in place parameter which is present inside drop function will be false. So let me show it here. In place, in place, in place. In place is a parameter under drop function, and what kind of value can you pass to it? We can pass only boolean values. By default it takes false, so even I did not change the value of in place here, so it takes false. What does that mean? Don't do any kind of in place operation. Okay, so it does not drop these columns from df, but these columns will be dropped in df1. So what makes the difference is, in line number 304, it is performing in place operation. That means in df data frame, these two columns make and model will be dropped, will be removed. So that is the purpose. I am not even storing to any of the variable, any other variable. See the sign again, the size will be same. Is it clear now? Why am I asking you guys to go through the documentation is, if you go through the documentation, you'll understand well. When you understand well, and if you do hands-on parallelly, you will grab well. You'll understand. You'll memorize for a long time. But just for name sake, okay, I have in place here. In place is equals to true. Just type in place is equal to true and execute. What is the use? There is no use, friends. Hands-on parallelly requires, understanding. Understand, then type each and every character, each and every letter. Okay. Then go and look at the output. That will be the sequence. That's how you have to practice. Then Akhil, it's going to take a lot of time then. Trust me, friends, only for the first time it takes time. Okay? It does not get repeated. But if you don't do it for the first time, when you will be asked a question on, say, any of these questions on these things, you cannot answer. So go through the documentation of functions at least from today, right? So now what I'm doing is I'll start working or I'll start building these dummy columns. I'll build the dummy columns, but I'm not using one hot encoding. One hot encoding is something that I'll do later. Then what is the first one that I have? Let us go and use get dummies. Get dummies is a function which is available and which is available in pandas module. Okay, and this particular function performs similar to one hot encoding. Okay, it performs similar to one hot encoding, but there is a small difference between one hot encoding and get dummies. We'll understand that further. See how simple I'm going to do it. PD dot get dummies, pandas dot get dummies is the function, and inside the function what am I passing? Df. What is df? My data. Okay, I'm passing the data. So with respect to this data, I want to create dummy columns, right? See how it is going to work in our case. How many non-numeric columns we have in DF? There are 3 non-numeric columns. So get dummies will work only on these 3 non-numeric columns. Okay. And as I have discussed, get dummies work similar to one hot encoding. Right. Done. Where am I storing the output? In df underscore new. So df underscore new is a data frame. Okay. So which is present here. What is the size? 428 is the rows, but Akhil, there is a increase with respect to columns. What happened? 12 became 21. Oh my god. How come? These are your numeric columns. So get dummies, not only get dummies, one hot encoding, label encoding, they don't work on numeric columns. They work only on non-numeric columns. Okay, apart from numeric columns, rest of the non-numeric columns were all encoded, and I see, the dummy columns got created. Okay, for better understanding, I'll go and hover my mouse on the column name. Type hybrid, type SUV, type sedan, type sports, type truck, type wagon. Okay, so that means the first column that we have in the original data is type. See, under this type, we have some categories, right? SUV, sedan, sports, then wagon. Okay, what else? Sedan, wagon, sports. All of these are different types that are present. Truck. Okay, under the type column. So what's happening is encoding is done. Encoding is done. You see, what is the first column? Type underscore hybrid. Like yesterday, what did we discuss? Gender underscore female. Why hybrid came first? Alphabetically, out of all the categories, H comes first. Okay, then type SUV. Okay, then type sedan, type sports. So type truck, type wagon. So in total, I see there are 5 categories under type column. Then next to type we have origin, the region from which that particular car is being manufactured. Yes. Okay. So origin Asia, origin Europe, origin US. So there are only 3 places. So 3 columns got created. Then the last one is drivetrain. It is drivetrain all, drivetrain, you know, front, drivetrain, rear. So these are the three columns, three categories available under drivetrain column. Depending on the original value, if that particular row has that particular value, it will be marked as 1. If not, it will be marked as 0. Only zeros and ones you will see. Clear? Similar to one hot encoding, same as is, but a small difference is what we observe, we'll discuss. So this is what get dummies do, but what else can I do with respect to this output? If that question raises in the mind, you tell me working on 21 columns will be faster or working on less number of columns will be faster. Working on 10 columns will be fast or working on 20 columns will be fast. Come on, friends. Obviously, less columns, faster the performance, right? So what I'm going to do is, I do the step again. I'm going to create the dummy columns again, but this time I will include one more parameter called drop underscore first, which is actually present inside this get underscore dummies. Okay, and I'm passing drop underscore first the value as true. The value that I'm passing for drop underscore first is true. Okay, so what actually this does? This will drop the first column post encoding for each and every category. For each and every non-numeric column which is getting encoded, the first category column will be dropped. So how many columns will be dropped? 3 columns will be dropped. One for type, one for origin, one for drivetrain. Okay, so obviously 21 will be 18. Where am I storing the output? df underscore new underscore 1. See. So it's better to work on this data frame instead of this, because 3 columns are less, obviously less number of columns, the execution will be fast, the performance will be fast. But Akhil, why did you drop? Who told you to drop? Because if you this is my df new and this is my df underscore new underscore 1. Okay, so here you have all the columns, and here I don't find type hybrid, then I'll not have origin Asia, origin Europe you'll see, origin USA will see, then drivetrain all is not available. But why did you do that? Even though if one of the column with respect to each non-numerical column was dropped, still you can understand what will be the original data. I hope it's making sense. Even though if these both are 0, can we comment on the original non-categorical data value with respect to drivetrain? Obviously, it will be all. Why? If these both are 0, the column that we have dropped, that is all, will contain 1. Yes. Making sense? So that's how we interpret and reduce the columns. Since you have only 3 non-numeric columns, 3 columns you can reduce. What if you have 10? 10 columns can be reduced by dropping the first column. Clear? Yes. I'll do the same with respect to one hot encoding. But before that, df dot columns will return us the columns present in the data frame. What columns were present inside the data frame? You'll get list of columns. Okay, then let us go and work with respect to one hot encoding. Okay, let us go and perform with respect to one hot encoding, friends. One hot encoding is available inside package called sklearn, also called as scikit-learn. Okay, sklearn is a package which is used for machine learning algorithms because majority of the functions with respect to ML algorithms are present inside sklearn module, sklearn package. Okay, so inside sklearn we have subpackage called preprocessing, and from preprocessing I'm importing only one function called one hot encoder. Done. Then this one hot encoder I'm initializing, okay, by passing one of the parameter, that is sparse output is false. I don't want to have any sparse output, so I'm keeping it as false. ENC. Okay. So if you see, it is pre-processing dot one hot encoder. Then what am I doing? I'm trying. This is my function now, friends. Similar to Winsorizer. Okay. So this is my function. ENC dot fit underscore transform. Fitting this function on the data. Okay. What is the data? Df dot ILOC of how many rows should be passed? Pass each and every row, but with respect to columns, pass only the first three columns. Column 0, column 1, column 2. Wait, what you are talking about? 0, false and true? Which one, friends? Yes, see, are you talking about get underscore dummies? What you are talking about? I don't understand. Sir, how true false change it to 0 1? Where did we get true? No, where did we get true false? First of all, where did we get true false? I don't see any true false. Question is, where did we get true false? See, in dummies when created, okay, it created columns in the data frame with true or false. Acha, friends. Okay, yeah, majority of you are trying to execute parallelly. That's okay, but that's what. See, my get dummies that I'm using is from pandas, right? And for the people who are also using get dummies, you know, you're also obviously using from pandas only. But no, for if you for the people who are executing it, you're getting true or false. For me, I'm getting 1 and 0. Right? Yes, the question is that one. Okay. The reason is because of the version of pandas. I'm using the older version of pandas, and might be since you have installed it, just before a month, you are using a new version of pandas. So that might be the reason. I'm able to see only ones and zeros. You'll be able to see true and false. Both are same. No worries. No worries, friends. Okay. So with respect to one hot encoding, what I'm trying to do is, you know, enc dot fit underscore transform, the function dot fit underscore transform on the data, and this is the data that I'm actually working on, all rows but three columns, and columns is equals to enc, the function dot get feature underscore names underscore out, a function which is available inside this particular thing. Okay, So this will return as the input features. So now it will make sense. Okay. So what is this additional thing that we are writing over here? Why are we writing it here? Because one hot encoding that you are actually performing on the data, you know, at the end of the day, you are converting the output to a data frame. What does that mean? It means the one hot encoding does not return a data frame. It returns something called as array. I hope you are aware of array. Okay, so since it is returning an array, it generally does not take the column names also. For that, I have to explicitly define the column names, take from these features, okay, dot columns. So these columns will be taken and finally creates a data frame back. Where are we storing it? In enc underscore df. See, this is the output of one hot encoding. The values are same, okay, but if you see, we have to explicitly convert the output to data frame back, and we should also specify the column names, okay, by passing it to the parameters. But did we do the same for get dummies? No, because get dummies being part of pandas, it by default returns a data frame, whereas one hot encoding returns as array. So this was encoded, right? The dummy columns. So what I'll do is I'll perform concatenation by taking this one enc underscore df and the numeric columns present in df data frame both will be concatenated with respect to axis 1, nothing but columns. So the output will be OHE underscore output, stored in OHE underscore output. If you see, the data frame is same again. At the end of the day, the values, everything is same. But how did we achieve is completely different compared to get dummies. In get dummies, by default, it returns a data frame, whereas one hot encoding returns array. Okay. So if you want to check, remove this one and try to see. Remove this pd.data frame and just execute only this line. You will get an array without having any column names and all. You will get an array. Right. Now let us also perform label encoding. For that, I am also importing label encoding from the same module. sklearn dot preprocessing import label encoding label encoder. Then, since these functions come from different modules, you have to initialize them initialized with the default parameters. I did not change any of the parameter, so I'm taking the default parameters as is. Okay. Then label encoder is the function now. Since I have stored it in label encoder, so the function will is label encoder. Label encoder dot fit underscore transform of df of drivetrain. Okay, on one specific column in df, that is drivetrain, I am applying label encoder, and the results are also stored in the same data frame but in a new column. Drivetrain underscore enc encoded. Let me open that. See, this is the original column and this is the output of label encoded column. All, which is alphabetically starting, first, then it takes 0, then front takes 1, rear takes 2. But how many columns do you see? There is only one column. That makes the difference between label encoding and one hot encoding. Clear? Let us perform label encoding on type as well. So the same process, just change the column. Let me open that. See, type is the original column, and this is where I see the encoded column using label encoding. Okay, so if you see hybrid takes 0, hybrid coming alphabetically first, then SUV takes 1, then what else we have? Sedan takes 2, sports takes 3, truck takes 4, and wagon takes 5. Okay, in that way I see one column encoded, which is the output of label encoding. Okay, so I hope it's clear with respect to label encoding and one hot encoding as well as get dummies. Get dummies is actually similar. It performs similar to one hot encoding. So in general, it's better if you go and use get dummies. You need not struggle with respect to the coding part because by default it returns a data frame. At the end of the day, we should have a data frame. So if you have a data frame, it will be very easy for you in order to do any kind of analysis. Right? Yes. Now let us go and understand. The next topic that we have is missing values. What if we have missing values? Okay, how should we handle such cases? Right? So these missing values, if you have in the data set, they negatively affect the results. Okay, so by default, there are some common strategies that we implement called as imputation. Okay, that we implement with respect to the data sets. Right? So we define our strategies and just impute the value. What are the basic strategies that we follow? We'll discuss. For that, let me refresh. Yes. Just cleaning up my settings and all. We have done. Right. I'm importing NumPy, a module for basic mathematical calculations. I'm importing pandas, a data manipulation module. Okay. Then reading data from an Excel sheet, Excel file. So this is the same data set, friends. But the thing is, in this data set, we have removed some values and there are some null values present in the columns. Okay, so let me show you. And how are we going to handle these null values is also something we are going to understand. Null values. See. Okay, there are null values in the data set and we are supposed to handle them properly. Okay, right. So how can you get the information about the data set? Just go and work with perform info function df.info. So this will return complete information. The make, I don't see any null values. Model, no null values, no. But if you see in drivetrain, there is a null value. I mean, how many null values do you find in drivetrain? How many null values are present in drivetrain, friends? There are 3 null values. How can we tell that? 425 are non-null. How many rows do you have? 428. 428 minus 425, 3. Then in MSRP we have four null values. Then MPGCT seven null values. Then weight three. So out of four columns we find that there are null values. Right. So either you can go and check with respect to info function to get the information about the data set, and you can also understand whether we have null values or not in the data. But if not, this is the general logic that we follow. A function that is available, that is an a df data frame object dot is an a will return us boolean values, friends. Okay, so it will check each and every cell present in the data frame. If there is a value, it returns true. If there is no value, it returns false. But am I just using only df.is as a function? No, I'm also additionally, keeping it as sum function, dot sum, which will sum up all the values with respect to each and every, you know, column. So we'll get the count of missing values in each column. See, understood? So I can clearly see these are the count. This is the count for missing values: 7, 3, 4. In MSRP drivetrain it is 3. So this is the count. Further, handling missing values is very simple. If you understand the logic, it's very easy, guys. There is a function present in sklearn, the same package that was used under encoding. Okay, but the sub package that we are using in case of imputation is different. It is impute. There it is pre-processing. Okay, sklearn dot impute import simple imputer. Yes, it's done. Simple imputer from impute sub package has been imported. Now let us understand how can we, define our strategies. For any column in general, what is the representative value? What will be the center value? We understood from the first moment. It is nothing but the mean value. The average value is nothing but the center value or the representative value of any numeric column. Okay, so what I am doing is I am directly imputing the missing values with the mean value. See, simple imputer is the function. I am just initializing it by specifying two parameters. Missing values should be identified with np.nan. So inside numpy we have nan. Okay, so if there is any np.nan null value, it is a missing value, and the strategy that is we are going to consider is mean. Okay, so if there is a null value, calculate the mean of the column and impute this mean value in place of missing value. I'm just initializing the function, so I'm storing it in mean imputer. Mean imputer becomes the function now. So mean imputer dot fit underscore transform. Okay, it is fit underscore transform. I'm fitting this function on the data, so I'm just working on one column. Okay, and I also want the transformed results, so this will apply mean strategy, calculating mean for this column, and wherever there are missing values, the mean value gets imputed. The mean value gets imputed. Where are you storing it? In the same column. The output, the transformed results should be saved in the same column of the data frame. So for that, after executing, in order to cross check, I am again going with the same logic. In this column, I am going with is and a function. So this will result me only true or false. When I specify dot sum, it will sum up all these boolean values and give me the count of missing values present in that column. It says 0. That means all the values present in this column got imputed. All the values in this, all the missing, excuse me, all the missing values in this data, in this particular column, mpg underscore city, got imputed using mean strategy. Akhil, what if the column contains outliers? Yes, you are right, friend. What if it contains outliers? We discussed that if the particular column, if it has outliers, mean is influenced by outliers, right? Then in that case, if that is the thing, we will go with median imputation. The process is same. Simple imputer, missing values is equals to np dot nan. So the null values, changing the strategy to median. Okay, so this particular line is actually initializing the function and storing it to an object. So the function will be median imputer. Using median imputer, I'll apply, I'll use this function to fit on the data MSRP, maximum suggested retail price. Okay, so I'll fit on this particular column, and I also want the transformed results to be stored in the same column. Same column. Then cross checking the logic. It says 0. So what can you interpret from this? I can say that using median value of MSRP column, the missing values present in MSRP got imputed. There is no missing value post performing median imputation strategy. Perfect. Then mode imputation. When can mode imputation work? When you want to work or when you want to impute any missing values present in non-numeric column. If you have missing values present in non-numeric, or it might be numeric also, but since mode can be also be calculated from non-numeric columns, mode imputation can be preferred on non-numerical columns, categorical columns. The process is same. I'll only change the strategy to most frequent. It is not mode. It is as most underscore frequent in the function. Most underscore frequent or mode, both are same. So don't use mode, you get an error. Keep it as most frequent. Then initialize the function. Okay. Then use that particular object as the function. Apply fit underscore transform on the data drive train. So this is again a numeric. Is it numeric? No, it's non-numeric, right? Drive train is non-numeric. So okay, in this particular column also there are outliers, drive train. So I am applying see, I am applying mode imputation. So whatever might be the major, the value which is repeated for more number of times gets imputed wherever we have missing values, right? So I'm cross checking using isNull.sum. Okay, so is any or is null both returns boolean values. When you try to sum up all these values, you'll get the number of missing values present in the column. So it became 0. Mode imputer worked. Finally, there is one more imputation with constant value. For example, if you don't want to go with any kind of mean or median or mode, okay, you can also go with the constant value imputation. What is this constant value? Constant value imputation is nothing but the strategy you have to keep it as constant and you have to define that constant value. So whatever the constant value that you will be defining, okay, you will be passing when the function is getting initialized. That particular constant value, in my case it is 3500. So this 3500 will be imputed wherever I have missing values in weight column. Okay, so no, taking the same function, the process is same, friends. Initializing the function, then applying fit underscore transform on the data, and cross checking whether the input it worked or not. Done, zero. At the end of the all sessions, all the techniques, I'm again performing info function to check whether is there any null value present in the data set or not. So this should show me each and every column should have 428. See, so that means all the imputers that we have defined, you know, it has executed successfully, and I see no null value present further. Do we have any function to find the most frequent entry? Yes. Mode, friend. Did you attend EDA class? Mean, median, mode, most repeated, right? So this is with respect to the imputation. Nothing but how are we going to handle missing values depending on the strategies. If you don't have outliers, then go with, and if it is a numeric column, then go with mean imputation. If it is a numeric column and if it has outliers, you know, you have to go with median imputation. If it is a non-numeric column, then go with mode imputation. Still, again, depending on the domain knowledge, if you want to go with any constant imputation, then you can also keep the strategy as constant and proceed. This is how we go and do imputation. We handle or we handle missing values present in the data, right? So there are two more techniques left, two more steps left under data preprocessing. One is transformations, and the next one is feature scaling or feature shrinking. So probably we'll discuss it in the next session. And it's time for our technical doubts, technical questions. If you have any kind of technical questions, yes, please feel free to share your questions. Friends, a sincere advice from my side. As I have discussed, you guys have to maintain one log sheet for errors. That will actually boost up in future. And whenever you are using any kind of function, just go and read the documentation of the function before you use that particular function. Okay, so that you'll understand well. That is my intention. That's it. You can maintain a cheat sheet. Thank you, friend. And in advance, happy new year to everyone. The link has been provided for the feedback form. Please share your valuable feedback before you leave. Excuse me. Missing values can be replaced by mostly mean or any other. That's what, friend. It depends on the type of data that we are working on. If it is numeric, we can go with mean, median, mode, or constant, whatever it might be. But what if that numeric column contains outliers? Mean is not that much, it gets influenced. So we'll go with median in that case. If the column does not have outliers, we'll go with mean imputation only. Okay? That we'll discuss, friends. There is no logic in order to just explain the constant imputation, I just took a value 3500 for weight column. That is my intention. That is just to explain how constant imputation works. That's it. Yeah. Thank you so much, friends. I wish you the same. May the next year bring lot of you know good health and good support, prosperous health for all of us. I wish you the same. But before you leave, hit on the like button and share across multiple channels if you feel these sessions are amazing. Alright, that's all for the day. We'll connect in the next session. Till then, signing off. Bye. Take care.